So I've got a couple of other examples that I want to do with solving systems of linear equations. So in this particular example, I have 10x minus 5y is equal to 30, and y is equal to 2x minus 6. Again, on this one, I'm actually going to use substitution because I already have one variable solved for. So I'm going to substitute this 2x minus 6 in for my y here. When I do so, that's going to give me 10x minus 5 times my 2x minus 6, and that's going to equal 30. Okay? Remember to distribute the negative 5 into the parentheses, so negative 5 times a negative 6 gives me positive 30, and a negative 5 times 2x gives me a negative 10x. I still have this other 10x sitting out here. Now notice what happens whenever I combine my like terms. 10x minus 10x gives me 0, so those go away. And I have 30 is equal to 30. I have no more variables, okay? So things have actually gotten canceled out. So when all variables cancel out, which they did in this case, I want to look at what is left. So look at the remaining values, which means in this case 30 and 30. And my question is, do they equal? Yes, 30 does equal 30, okay? So if the values equal, or the values are equal, what this means is that these two equations are the same line. Meaning I can put in any value that solves this one over here, and it will also solve the second one. So whenever all the variables cancel out and the remaining values are equal to each other, they're the same line, there are infinite solutions. Remember we talked about the 3 different types of solution values? And in all of our examples so far, we've had one solution. Well, here's one where we have infinite solutions because they're that same line. Okay? Let's look at another example. This one has fractions. Let's first talk about getting rid of some of these fractions. You can get rid of these fractions in this first equation by multiplying by a common denominator. Well, common denominator here would be a 3. So whenever I distribute this 3, I get 3x plus, think of this as over 1, so that's 3 times 5 is 15, 1 times 3 is 3, and then 3 times 1 is 3, 1 times 3 is 3. Now I'm going to simplify these because 15 divided by 3 is actually 5, and 3 divided by 3 is 1. Now I have a much nicer equation to work with. I'm going to do the same thing for the second equation, but on the second one I don't want to multiply by 3, I want to multiply by a common denominator, which in this case I'm going to do 2 over 1. So I get 2 times 3 is 6 over 2x, 2 times 5 is 10 over 2y, and 2 times 2 is 4. 6 divided by 2 is 3. 10 divided by 2 is 5. And then I have my 4. These two equations are much nicer, okay? Now I can solve by substitution. It would mean that I would have to solve one of these for x or for y. But I'm probably just going to use elimination. They're already in the x plus y equals a variable form. Or I'm sorry, a number form. And so what I can do is I can multiply this second equation by just a -1, because notice if I multiply this by a -1, it gives me that -3. So I'm going to have a -3x, distribute that -1, so -1 times 5y gives me a -5y. -1 times 4 gives me a -4. So now I'm just going to add these two together. And I'm going to get 3x minus 3x, which is 0x. 5y minus 5y is 0y. 1 minus 4 is a -3. Well, these two just canceled out and gave me 0 is equal to a -3. Okay, so all of my variables canceled out. Remember what I said, whenever all the variables cancel out, look at the remaining values. In this case, they do not equal each other, okay? So if they are not equal, which in this case they are not equal, then the lines are parallel. Meaning that they increase or decrease at the same rate. And if you recall from one of the other videos, we talked about the parallel lines. There are no solutions for this. They never cross. Therefore, there are absolutely no solutions for this set of equations. So again, you can have one solution like we've had in previous. You can have that infinite many solutions like we had right up here, where the variables all canceled out and I have one number equal to itself. Or you can have no solutions like we had right here, where all the variables canceled out and I have a number that's equal to a different number, which can't happen. So this one's a no solution possibility. So try some more of these with addition and substitution, and then if you have questions, let me know.